Hi, I'm Sammy, and today we're going to be going over Combo Breaker. Combo Breaker is a motorized, battery-powered, 3D printed Arduino-based device that can crack any master combination lock in under 30 seconds. First, let's see it in action, and then I'll go step by step in how I designed and built this and how you can build your own. If you haven't seen my previous videos on cracking master combination locks, check those out first. In the first video, I go over how to crack any master combination lock in under 2 minutes with less than 8 tries without any device at all, just using your hands and an online tool I built for you. In the second video, I actually drill open a combination lock so you can see what's going on inside, how it works, and how the vulnerability works. Now in this video, I'm actually going to go step by step in building the Combo Breaker yourself. First, let's go over a simpler version of Combo Breaker that you can build much quicker and for much cheaper. And we'll understand some of the basic components and then go from there and build the more advanced version. First, let's determine what kind of motor we need to actually control the dial. We'll obviously need to turn the dial both ways, and we'll need some pretty fine controls. At first, I thought about using something like a DC motor. The problem with a DC motor is that even if you control it really quickly or really slowly, for the most part, once you tell it to stop, it's not actually going to stop. It will actually free run for a little bit. So a DC motor wouldn't work in this scenario. You could also use an optical encoder or some sort of rotary encoder on the back to determine what position it's in. But again, as soon as you stop it at the right position, it will continue to run. So the DC motor was out. I also thought about potentially using a servo motor. The servo motor, you could use a continuous rotation so that it could rotate continuously, but the servos are pretty slow because they're geared to have torque rather than to quickly control. And inside it's really just a gear motor, so we might have some of the same issues. Ultimately, I decided to use a stepper motor. In this case, you can get a stepper motor pretty cheap, like this guy right here. You can get them on eBay, and I actually link to a stepper motor that I used from the website. And in my case, I wanted to actually use a smaller stepper motor. So I found this guy, which is called a pancake stepper motor, just because it's so thin, but it's also pretty powerful. Another thing I did was I calculated how fast it would rotate compared to other stepper motors so that I'd have one that could rotate at least a few times per second, which is pretty impressive for steppers as they're really meant for precision. The nice thing about a stepper motor is that it's very precise. When you tell it to go somewhere, it pretty much will, unless there's too much force. And as soon as you tell it to stop, it stops at that position. The next step in driving a stepper motor is to use a stepper motor driver. I used initially an easy driver. An easy driver is a breakout board for the Allegra A3967 stepper driver. And this supports up to 30 volts and 750 milliamp for your stepper motor. My stepper that I was using could actually go up to an amp, so I wanted to drive it a little bit faster, so I actually upgraded to a smaller stepper driver, which is the Allegro A4988. And that's this little guy here. You'll also see there's a little dial on there that allows you to actually control the current output. So you don't want to overdrive your stepper motor, so you'll actually want to control this and make it a little less than what your stepper is rated for. For the brains of the device, I used an Arduino Nano, specifically running an ATmega 368, and I used a 5-volt version. I like the Arduino Nano. It's easy to use. It has USB for fast programming, and it has an onboard voltage regulator, so you can give it up to 20 volts and it'll bring it down to 5 volts. Now let's actually figure out how we're going to connect the stepper motor to the dial so that the stepper motor will turn the dial. For this, I learned some basic CAD so that I could produce a 3D model and then have it 3D printed. If you don't have access to a 3D printer, you should look for a local hackerspace or makerspace in your area. I go to CrashSpace in Los Angeles. Those guys are awesome. They've taught me so much in many of these areas. Additionally, if you don't have a hackerspace or makerspace where they don't have with a 3D printer, what you can do is you can go online and send a 3D model, and I'll include some links to places that you can do that where they'll then ship you a printed piece. So let's get some measurements here. Let's understand the size of the motor shaft, the stepper motor shaft. So this looks like a standard sort of 5mm stepper motor shaft. You'll note that this is actually shaped like a D rather than a circle. So we need to understand both of those measurements, and we'll write these down. So we know it's 5 mil for the widest part, and for the shortest part, the shortest diameter is about 4.5. Okay, so let's write that down. So here's our stepper motor. Just make a really big shaft here. Actually, oops. It's actually a D. That's what it is. All right. So here we have our 5 mil, and then we'll call the shorter piece, and we'll just write over here, 4.5. Okay, and for our lock, we have the dial. So let's figure that out. And the dial itself actually is wider on the inside, closer to the numbers, and thinner on the outside. So let's get those both measurements. All right, let's just understand sort of the widest. So it's 19, about 19 mil. It actually goes down to 18, but 19 should suffice. And also, let's see about how long is it? It's about 8 mil. Close enough for this. So let's just do our lock here, and then we have our dial. So we will say this is, call that 19 mil, and we said it goes in about 8 mil. Man, it's handwriting. I never get past middle school. Okay. Cool, so now let's draw it up. Now for this project, I learned some basic CAD and 3D modeling. I'm using Autodesk Fusion 360. I like it because it works on OS X and Windows. It's free for 30 days or free for 3 years if you're a student. Also, Autodesk has some other software like 123D Design, which is indefinitely free. Also, if you can, get a copy of their older software called Inventor Fusion, which is also entirely free and is pretty good. It's actually faster than Fusion 360 and more powerful than 123D Design, although it's end-of-life. It's not as current as those software. But they're all very similar, and Autodesk themselves have great videos on their YouTube, so you can actually learn how to use the software pretty quickly just by going through their videos. First, we'll draw the shaft here. It's a D ring, essentially, or a D shaft, and we'll give it a millimeter around of thickness for the body. And now we'll want to extrude it or pull it up 15 millimeters, the length of our shaft here. Yours may be different. And now we'll want to grab the dial. So that's 19 millimeters, and we'll also want a millimeter around. So we had 2 millimeters for 21, 1 mil on each side. Give it 1 millimeter of thickness here. Now let's go ahead and grab the dial. So that was 9 millimeters. It was actually around 8, but it's okay from some space. And let's add teeth to this guy so that it will actually grab onto the grooves within the dial pretty well. Let's create one tooth here, and let's extrude it. Actually, let's make it a separate body, and let's pull it down to the bottom here. And now we can actually pattern this around the origin. The origin is the center of our 3D space here. And we'll create 8 of these. All right, now we have that. Let's just combine the different bodies together into one piece, so it just prints as one piece. And let's fillet the edge here, make it a little pretty. And that's that. Awesome. All right, so here's our first version using an Arduino Nano, the Easy Driver, the stepper motor, and our 3D printed model. And we just have a slow turn here. You can see how it holds on pretty well. It's pretty strong grip, so even if I'm holding it like upside down, there's no problem. Both sides are gripping on really well here. And it's actually really easy to pull out and put back on, no problem. Those teeth grip really well. And now we can start brute forcing. Now, this is the simpler version, right? So there's no way to test for the vulnerabilities in our first version or in the first videos that I demonstrated. And we also have to manually pull on the shackle. With the more advanced version, we don't have to pull on the shackle. We actually have everything done for us. We have a stepper motor, and on the end we actually have this optical rotary encoder, which actually determines where the location of the dial is. This way, when we're pulling up on the shackle and we can't turn the dial, the stepper motor knows, or actually our software knows that the dial is not turning. Additionally, with the servo I'm using here, we also have an analog feedback, which tells us the position of the servo horn here, so that we know if we're hitting the shackle and we can't lift any further, if we can't, let's say, open it, then we know we did not open successfully and can return back down. And you can see everything on here. So now that we have this first one down, we can create some basic software to brute force. While we're doing this, you would have to manually open it, but let's see how fast we can do some brute forcing here. So it looks like it only takes under 2 seconds per combination, even with our simplified device. In the next video, I'll go over the advanced combo breaker and how I designed it, why I chose the pieces I did, such as the optical rotary encoder on the back and the analog feedback servo over, say, a solenoid, and other design and code decisions in building this entire thing. If you enjoyed this video, please hit like and subscribe. Also, if you'd like to get more sneak peek videos and first looks at the hacking tools I'm creating and research I'm doing, please join my mailing list. You can subscribe from my website at sammy.pl. Thanks. Bye.